Hello students, now in this video we are going to discuss about 11th standard computer science chapter 8 iteration and recursion. We already learned the concept of iteration. As what is meant by iteration? Repeating some process again and again is known as the iteration for specified number of times. Okay, how many times we are repeating? Depending upon the requirements, we are repeating the certain number of times. This type of process is known as the iteration. Okay, so there are several problems which can be solved by doing the same actions repeatedly. We are repeating the same action. Both iteration and recursions are algorithm design techniques to execute the same actions repeatedly. Okay, iteration and recursion, both of them is based on the algorithmic design technique. So now you can see what is the use of repeating the same action again and again. Even though the action is the same, the state in which the action executed is not the same. Okay, for each and every time the state is not the same. Depending upon the value, the state is also changed. Okay, so each time we execute the action, the state changes. So for each and every time we execute the actions, the state can be changed. Okay, therefore the same actions is repeatedly executed but in different states. The states changes in such a way that the process progress to achieve the desired input output relationship. If for example in the last chapter we discussed one example idli. Okay, for eating idli, so if your mother has placed four idlis for you, okay, in a plate, the process of eating is repeated for completing that four idlis. For each time we are taking the idli, the size of the idli and then number of idlis can be changed. Okay, what is the output the mother can be expected? The mother can expect the plate must be empty. Okay, so what is the input is given? The mother giving four idlis in a plate. Okay, so what is your process? What is the child actions? They want to take all the idlis one by one. Okay, so for each and every time the child take the eat the idli, the state of the idli can be changed. That is number of idlis and size of the idli is also changed. Okay, so this type of process is known as iteration. We are repeating the same process. That is, eating idli is repeated again and again, but the state of the process can be changed. That is, number of idli can be reduced. At last we get the output, that is empty plate. Okay, so this type of process is known as the iteration process. Okay, iteration. In iteration, the loop body is repeatedly executed as long as the loop condition is true. So it repeats some set of statements again and again until the condition is false. Okay, once the condition is true, the body of the loop can be executed. The body of the loop can be repeatedly executed when the condition is true. Okay, so when it stops, when the condition is goes on false. Okay, so each time the loop body is executed, the variables are updated. For every time the control variable is updated, you have to check the value whether we reach to the end of the number of times is specified. However, there is also a property of the variables which remains unchanged by the execution of the loop body. This unchanging property is called the loop invariant. Okay, so if the property of the variable is not changed, then that variable is known as the loop invariant. Loop invariant is the key to construct and to reason about iterative algorithms. Okay, so in the next topic we discuss about what does mean by loop invariant, how we can identify the loop invariant at all. Okay, recursion is another algorithm design technique closely related to iteration but more powerful. We already know recursion means a function can call itself is known as a recursion. Using recursion, we solve a problem with a given input by solving the same problem with a part of the input and constructing a solution to the original problem. So we divide a problem into small subproblems and we construct a statement of solving that small problem and finding the solution of that problem and find the solution to the given problem. Okay, so a function can call itself is known as the recursion. from the solution to the partial input. Okay, we are going to find the solution to the original problem from the solution to the partial input. Is known as the recursion. Now we see about what is meant by invariant with example. Suppose the following assignment is executed with u comma v is equal to 20 comma 15. We can annotate before and after the assignment. Okay, so first we give the values 20 and 15 to the variable u and v. Okay, so u equal to 20 and v equal to 15. We assign the value, that is u and v. Now we are using the assignment statement to change the values of the variable. So u comma v is equal to u plus 5 comma v minus 5. That is, we are going to add number 5 to the value of u and subtract number 5 from the value of v. So after the assignment, what is the changes is there? U plus 5, that is, what is the value for u? 20. So 20 plus 5, we get the total 25. And then what is the value for v? 15. 15 minus 5, what is the value for v now? 15 minus 5 is equal to 10. Now the value of v is 10. Okay, after the assignment, u comma v is equal to 25 comma 10. But what do you observe about the value of the function u plus v? So now you can see the function u plus v. What is the value? Before assignment, what is the value for u and v? 20 plus 15. That is, the value of u is 20 and then value of v is 15. We get the total 35. After the assignment, what is the value? It will be changed. The value of u is 25 and then value of v is 10. So totally 25 plus 10 is equal to 35. So before the assignment and after the assignment, the value of u plus v cannot be changed. The value of u plus v is having the same value, that is 35. Okay, so the value is not changed. The assignment does not change the value of u plus v. We say that u plus v is an invariant. That is, the property of u plus v cannot be changed. It is an unchangeable state. So we call it as a invariant of the assignment. We can annotate before and after the assignment with the invariant expression. That is, before u plus v is equal to 35. U comma v is equal to u plus 5 comma v minus 5. That is, we are doing some process we can say u plus v is an invariant because it is 35 before and after the assignment. The property of u plus v is not changed. Okay, or we can say u plus v is equal to 35 is an invariant. It is true before and after. Now you can see another example for loop invariant. If we execute the following assignment with p comma c is equal to 10 comma 9, that is, the value of p is 10 and then value of c is 9. After the assignment, the value of p and c is equal to 11 comma 10. Okay, so the value of p is incremented by 1 and then the value of c is also incremented by 1. Now you can see the statement. So what is the value is given for p and c? So before the assignment, p comma c is equal to 10 comma 9. Okay, so after the assignment, what is the assignment statement? We are increment the value of p and c by 1. Okay, so p comma c is equal to p plus 1 comma c plus 1. So after the assignment, what will be the changes? We are changing the value of p and c. So the value of p is now 11 and then value of c is 10. So can you discover an invariant? Is that invariant? Now you can see this one. How we can find the invariant of this value? So what is the value of p minus c before and after? Okay, so p minus c is equal to 10 minus 9. What is the value of p? 10 and then value of c is 9. So 10 minus 9 is equal to 1. And then after the assignment, what is the changes? P minus c is equal to, what is the value for p? 11. And then what is the value for c? 10. So 11 minus 10 is equal to 1. Now you can see before and after the assignment, the value of p minus c is cannot be changed. So the p minus c is the loop invariant. Okay, we find that p minus c is equal to 1 is an invariant. In general, if an expression of the variables has the same value before and after an assignment, it is an invariant of the assignment. Okay, so in this expression, which expression? P minus c, before and after the assignment, the value of the expression p minus c is cannot be changed, so it is known as the loop invariant. Okay, let p of u comma v, here the expression is p, the variables are u comma v, be an expression involving the variables u and v. So p of u comma v, so u comma v equal to expression 1 comma expression 2, that is e1 comma e2, is obtained from p of u comma v by replacing u by e1 and v by e2 simultaneously. Now you can prove that invariant p of u comma v, that is expression of u comma v, is an invariant if an assignment u comma v is equal to e1 comma e2. If p of u comma v within expression u comma v is equal to u1 e1 comma e2 equal to expression of p of u comma v, that is the expression is invariant because we are getting the same expression after the assignment expression of u comma v, so this statement is also invariant. Now you can see one more example. Show that p minus c is an invariant of the assignment p comma c is equal to p plus 1 comma c plus 1. Let p of p comma c, here p is used to represent the expression. Okay, so here two variables p and c is equal to p minus c. Then p of p comma c, what is the value is substituted for instead of p and c? The value of p is equal to p plus 1, and then value of c assigned assignment statement is c plus 1. We are changing the value p by incrementing the value of p by 1 and c by increment the value of c by 1. Okay, so is equal to p minus c, within bracket p comma c is equal to p plus 1 comma c plus 1. Now you can substitute the value of p and c in this expression p minus c. So in the place of p, what you have to replace? P plus 1 minus, and the value of c, what is the value is there? C plus 1. Okay, now you can multiply minus inside of this expression. So p plus 1 minus c minus 1. So plus 1 minus 1 will be cancelled. We get p minus c. Now you get the same expression p of p comma c. So since p minus c of p comma c is equal to p plus 1 comma c plus 1 is equal to p minus c. So the expression p minus c is an invariant of the assignment p comma c is equal to p plus 1 comma c plus 1. So consider one more example, that is two variables m and n. Under the assignment m comma n is equal to m plus 3 comma n minus 1 is an expression m plus 3n an invariant. Let p of m comma n, here the expression is p, m comma n are the variables. Okay, so is equal to m plus 3n. Then they just take the expression to substitute this value in the place of m plus 3 comma n minus 1. Okay, so here the value of m is m plus 3 and then value of n is n minus 1. Okay, so what is the expression is given? M plus 3n. Now we can substitute the value of m in the place of m, that is m plus 3. So what is the expression is given? M plus 3n. What is the value for m? M plus 3 plus what is the value for n? So 3 into n minus 1. Now we can multiply this 3 inside of the bracket. Okay, so m plus 3 plus 3 n minus 3. Now plus 3 and minus 3 will be cancelled. We get the expression m plus 3n. Okay, so we get the same expression p of m comma n. Since m plus 3n, m comma n is equal to m plus 3 comma n minus 1. It gives m plus 3n. So m plus 3n is an invariant of the assignment m comma n is equal to m plus 3 comma n minus 1. So this type of expression is known as the loop invariant. So in the next video we discuss about the more examples of loop invariant. Okay students, thank you.